Okay, so the last couple of days we have been looking at polynomial graphs, and we have been looking at where they bounce, they wiggle, and they cross, and sketching graphs from a polynomial. Now this first part of the lesson video is going to go the other way. I'm going to give you a graph, and you need to figure out a possible equation for each graph. Okay, so if we look at the first one, so let's just zoom in on our first graph. There's a couple of things we want to make sure we notice, and it should be things that we're thinking back from what we learned in our previous two lessons. First thing that I notice is that both ends of my graph are going up. That tells me that I have a positive lead coefficient, so that tells me I have a positive A value. Remember, A is just your lead coefficient because they're both going up as positive, and then my total exponents, if I add them all together, is going to be even because they are both ends are going in the same direction. So that's the first thing that I notice about my graph. The second thing that I notice is that I have things happening on the x-axis at -3, -1, and +2. So when I go to write my equations, I need to think about the multiplicity there at each of those places. So if I look first at -3, I notice that at -3, it crosses the x-axis. And if you think back to what that means, if it crosses the x-axis, that means my multiplicity, my exponent, is going to equal 1. If I look here at -1, I've got a wiggle. Okay, so when it wiggles, that means I have an odd exponent. And in this case, whenever we write the equations for right now, we are going to use the lowest odd or the lowest even exponent. So in this case, we are going to use a 3 as our exponent because that's our lowest odd number. And then over here at 2, I bounce. And when I bounce, that means that my exponent is even. And it also means then if I use my lowest exponent that's even, I'm going to call it a 2. So then when I go to write my equation, remember if we say that it crosses at -3, that means my factor is going to be x plus 3. My exponent that goes along with it, in this case, is going to be 1. You can either write the 1 there or you can just leave it without it. And then my second factor at -1, which again, if we cross or wiggle or do anything at -1, that means it's going to be x plus 1. We said it wiggled there, so we are going to have that x to the third power, or excuse me, x plus 1 to the third power. And then the last one is at +2. So in my parentheses with my factors, I'd have x minus 2, and we'd have an even because it bounces, and in this case, our lowest even is going to be 2. The last thing we want to look at is to make sure, do we need to have anything out in front here as our A value? Well, we said from the very beginning that our A value is positive, okay? And if you want to put a positive value out in front there, we are not actually going to figure out the exact number based on the graph that goes out in front. You just need to know if it's positive or negative. And in this case, it would be positive because they both go up in the positive direction. So that is an example of a possible equation for that graph. Okay, so then if we move over here, again, we've got a lot going on here. First thing that I notice is that the graphs go in opposite directions. This guy is going up, this guy is going down. And the general direction from left to right is negative. So that means since it's going in opposite directions, my total exponents are going to be odd, and my lead coefficient is going to be negative, so my negative A value. Okay, so then we look at what's going on at the x-axis at -4. Right here, it crosses, so that means we're going to have a exponent value of 1. It also crosses here, which means we are going to have an exponent value of 1. It also crosses at +1, so our exponent with that factor is going to be 1. And then at 4, it bounces, and bounces means our exponent will be even. In this case, we're going to use our smallest even exponent, which is 2. So if we are going to write our equation, okay, at x equals -4, again, remember that that means we are going to write it as x plus 4. That our exponent is going to be a positive 1. At -2 means we are going to write x plus 2. And again, our exponent is going to be 1 because it crosses. At positive 1, which in our factored form, that would be x minus 1, is also going to have a a 1 as our exponent. And then at 4, which again in factored form would be x minus 4. And since it bounces, it's going to be squared. The only other thing we need to remember is that that graph is going down from left to right, which means it has a negative lead coefficient or a negative a value. So we would just need to make sure we put a negative out in front. And then we can just double check if we add all of our exponents together. 2 plus 1 plus 1 plus 1 is 5, which is odd, which is good. That means they should be going in opposite directions. Okay, so why don't you go ahead on this second slide, pause the video, write what you think would be the possible equation that goes along with that graph, pause it, write it, and then you can check with what I have here when we get done. I'm not going to explain these two. If you have questions on it, please feel free to ask me. Okay, so if you take a look at what I have here, the one on the left, I know it had to be negative lead coefficient out in front because both of the arrows are going down. And then I just looked at the places on the graph, figured out bounce, wiggle, cross to figure out which exponent goes with each of my factors. And then on my other one here, my one on the right, they both are going up. So my lead coefficient out in front would be positive. I can just leave it as nothing there because that means it's positive. And I wrote my factors based on what it did at the x-axis. So now we are actually going to move on to some different information. So this week we've been looking at polynomials and graphs in factored form. Today we will look at standard form and find the real and imaginary solutions using synthetic division. Okay, so factored form, this is what we've been looking at earlier in the week. We could tell a lot about the graph from that, and all of those solutions were real and things like that. Now we are going to look at standard form and see what happens if you have any imaginary solutions and you use synthetic division, repeated synthetic division in order to find that. So we'll talk about what that looks like. Okay, so what we're going to look at is sometimes there are solutions that are repeated. Okay, how do I know if it has a repeated solution? Meaning a repeated solution would be like a bounce. Okay, because remember when it bounced, it was like x minus 2 squared. Well, that means that x minus 2 is a solution twice. So anytime you have x minus 2 or something like that squared, that solution is there twice, and you would have to use that. And then we are going to talk about here in a second how to find all the zeros, real and imaginary, and using that fundamental theorem of algebra that we have already talked about to determine how many solutions a polynomial will have, so we know when we do synthetic division how many solutions we're looking for. So just a reminder of what that fundamental theorem of algebra actually is. Basically, in nice, simple words, the highest degree of the polynomial, okay, and keeping in mind we're in standard form now, that highest degree of the polynomial tells you how many solutions it will have. So we are no longer in factored form, we are in standard form, which means you'd have a x to the fourth, x to the third, x to the second, x to the first, x, and so on. And you would look at whatever the highest degree is. So for instance, if we had this, f of x equals 3x to the fourth plus 2x squared minus 3x plus 9, something like that. My highest exponent in standard form is 4, so there would be 4 solutions, either real and or imaginary. Okay. So here is how you can figure out what those solutions are, because a graph in Desmos is not necessarily going to tell you everything that you need to know. So what you're going to do, first of all, is look at this equation. You have g of x, could be f of x, equals x to the fourth minus 3x plus 9x squared minus 9x. first thing you ask yourself is, when I look at my graph in Desmos, how many solutions am I looking for? How many solutions are there? Well, my highest exponent is 4, so there are 4 solutions. Okay, so now what we're going to do is we're going to leave our screen here and go to Desmos, and you're going to put this equation into Desmos. Okay, so when you do that, you should be able to look at the graph and know where it crosses the x-axis at. Okay, so if you went to Desmos and put in this equation exactly like it's written, you would have a graph that looks like a parabola, essentially. Okay, so it would cross at 0 and it crosses at 1, and it goes like this. Okay, so we know this is 0, this is 1, x equals 1, there we go. So we know that 2 of our solutions, we're looking for 4, but only 2 of them can you tell just by looking at the graph. So our real solutions occur at 0 and 1. What we need to find then is there's imaginary solutions, those solutions that you can't see just by looking at the graph. We have to actually do a little bit of math to figure out what those are. So we know that there should be 2 imaginary solutions. Okay, so we are going to have to figure out how to find those 2 solutions. Okay, so in our steps here, it says how many solutions, there's 4. We found the real zeros. There's 2 real zeros. Are there any repeated zeros? Is there any way, when you looked at the graph, was there anywhere it bounced at the x-axis? And if you looked at your Desmos graph, it did not bounce anywhere. So there's no repeated zeros. There's no bounces. And yes, there are 2 imaginary solutions. So we are going to use repeated synthetic division to find all of the rest of the zeros. Okay, so the way that that works, okay, here's a key thing, is that 0 and 1 are 2 real solutions. 0 and 1 are factors of the polynomial. So when you divide, there will be no remainder. That's what the definition of a factor is. There will be no remainder. Okay, so if we take our solutions that we have, 0 and 1, and synthetically divide from our polynomial, we should divide and be able to get down to a place where we can actually solve. So let's go ahead and do that. So we have, first thing we're going to do, we need to divide by each of our real solutions. So the first thing we're going to do is divide that original polynomial by 0. In synthetic division, you can actually divide by 0. It's not like the rest of the math world where you can't divide by 0. So remember, if we are dividing by 0, that 0 goes out on the outside. We have our upside down house, and we put all of the coefficients inside of our house. So we're going to have a 1, a -1, a +9, a -9, and since there is not a constant, every power has a place, so even though there's not a constant, we have to fill in that missing place with a 0. So then we're going to synthetically divide, so we're going to bring down the 1, multiply around, 1 times 0 is 0, add to get -1, -1 times 0 is 0, add to get 9, 9 times 0 is 0, add to get -9, -9 times 0 is 0. Okay, so our remainder is 0, which is what we wanted. So now what we have left here, we are going to synthetically divide again by our other factor. And the easiest way to write that is to just put our other factor, which in this case is 1, right out here. Oops, put it in a 1. And then we are going to synthetically divide what we have left. Okay, so then, oops, I'm running out of space here. I'm going to bring down my 1, multiply around, 1 times 1 is 1, add, -1 plus 1 is 0, 0 times 1 is 0, add, 9 plus 0 is 9, multiply around, 9 times 1 is 9, add, And again, I did it correctly because my remainder is 0. Well, what I'm left with right here is 109. Remember those leftovers that we have there we can write into a polynomial. And we started out with a 4th power up here. We divided once, so that would give us a 3rd power. We divided a 2nd time, which would leave us with a squared power. So that means that we are going to have 1x squared, and I'll just write it all out here, plus 0x plus 9. That is our last factor that we're going to have to solve in order to figure out our imaginary solutions. So I'm just going to rewrite, and we want to set it equal to 0, because anytime we find solutions, we set things equal to 0. I'm just going to rewrite that as x squared plus 9 equals 0, because anytime you multiply by 0 here, we don't really need that. And in order to get x all by itself, okay, I'm going to subtract 9 from both sides and get x squared equals -9. If I take the square root, x will be plus or minus, remember we always have two solutions, the square root of -1 is I, the square root of 9 is 3. So we'd have plus or minus 3i. So our other two solutions, our imaginary solutions up here, are going to be -3i and +3i. So now we have 1, 2, 3, 4 solutions, which is what we were looking for. Okay, so let's try that one more time. Okay, if you go ahead and put x to the 5th plus x to the 3rd minus 2x squared minus 12x minus 8 into Desmos, okay, it will look kind of like this. So there's the basic graph that you get when you put that into Desmos. And keeping in mind, we are looking for 5 solutions, okay, because our highest exponent was 5. So our real solutions that we know just by looking at the graph, okay, well, at -1, it bounces. Remember, a bounce is a repeated solution, which means -1 repeats 2 times. So -1 and -1. Okay, at that bounce, that tells me it's an answer, or it's a solution to this polynomial twice. At +2, it crosses, and at a cross, that means it just is once. So we have 3 out of the 5 solutions, which means we are going to have to synthetically divide 3 times, and then what we get at the very end, we are going to have to solve in order to figure out what our imaginary solutions are. So let's go ahead and start, and it doesn't matter which real solution you start with. You can start with the -1 in any order, because when you do the synthetic division, it doesn't matter which order you go. So let's start with the -1. Okay, so we'll take our -1, and we are going to put in our our coefficients. So we'd have 1. Stop and think. Every power has a place. We are missing a 4th power, so we're going to have to fill in with a 0. 1, -2, -12, -8. Okay, so we bring down that 1, multiply around to get -1, add to get -1, multiply to get +1, add to get 2, multiply around to get -2, add to get -4, multiply around, get +4, add to get -8, multiply around, +8. When we add them, we get 0. If you do not get a 0 right there as your remainder, you have done synthetic division incorrectly, because remember, each of these factors, the real solutions, will divide evenly into the polynomial. So if that is not a 0, go back and double check that you've done it correctly. Okay, so now we've done 1 of our real solutions. Now we're going to use the second one. So now we're going to take -1, and we are going to divide out the leftovers. So now we're just going to put another -1 there, bring down 1, multiply around, add, you get -2, multiply around, add, you get +4, multiply around, add, you get -8, multiply around, add, you get +8, 0. Okay, so we're good so far. I've got the remainder of 0 twice, so now I've done that -1. Now, I have one more time I've got to synthetically divide. So I've got a 2 that I need to synthetically divide by, and I am going to just divide that out of what I have left over, bring it down, there's my 1, multiply around, which is 2, add to get 0, multiply around, which is 0, add to get 4, multiply around, which is +8, add, and again, I know I did it right because my remainder is 0. I have synthetically divided by all of my factors, my real solutions, and I am left with 104. Okay, that 104 tells me what my equation is that I need to write in order to solve to find my imaginary solutions. Well, I started with a 5th power. I divided out a -1, that would be a 4th power. Then I divided again, would be a 3rd power. Divide again, so this is going to be an x squared down here. So I'm going to have 1x squared plus 0x plus 4 equals 0. When I go to solve that, I subtract 4 from both sides. I get x squared equals -4. When I take the square root of both sides, I get x equals plus or minus. I pull that negative out to make it an I, and the square root of 4 is 2. So I'd have plus or minus 2i. So my imaginary solutions up here, my real solutions are listed. My imaginary solutions, let's put those back into black. My imaginary solutions are going to be at -2i and +2i. So now I needed 5. I got 1, 2, 3, 4, 5 solutions, which is what the fundamental theorem of algebra tells me that I should have gotten. Okay, let's look at one more. This one is actually going to be quite a bit easier. You'll see why when you go ahead and put it into Desmos. So say, how many solutions am I looking for? I am looking for 3, okay, because my highest exponent is 3. If you go into Desmos and put it in there, look and see what you get, and then let's come back and find your real solutions. So right here is what the graph looks like if you put it into Desmos, and what you find is at -3 it crosses, so my real solutions, okay, it crosses at -3, so I know -3 is one of my solutions, and it bounces at -2. That should be at -2, not -1. Let me fix that. So it should bounce at -2, not -1. And when it bounces, remember, a bounce is a repeated solution, which means -2 is a solution twice. Now ask yourself, why is that an easier problem? Well, how many solutions were we looking for? 3. How many solutions did Desmos give us? 3. Do we need to synthetically divide? No, because we have all of our solutions. So anytime Desmos tells you all of your solutions, you don't actually have to do any synthetic division. So this one is a nice, easy one to end on because all 3 of your solutions are actually given to you in Desmos because they are all real solutions and there's no imaginary. So good luck.